Question 5 is about entropy and Gibbs free energy change. So we've got some entropy values for each of these substances here, and we've got an equation. Use the equation to calculate Gibbs free energy change and then explain why the reaction is feasible. In other words, if it's 0 or less than 0, 0 or negative. So let's have a look then. So for entropy change, the entropy change is the sum of the entropy of the products, the entropy of these on the right hand side, take away the sum of the entropy of the reactants. So entropy change is this one, 2 moles of CO, so 2198, 1 mole of titanium chloride, which is a 253. Subtract the sum of the entropy of the reactants, so that's subtract a TiO2, which is a 50.2. Subtract, I've got 2 moles of carbon, so 2, subtract 2, 5.7s, and subtract 2, 2, 2, 3, because I've got 2 moles of Cl2. I can calculate delta S then, but that's in joules per Kelvin per mole. And it needs to be in kilojoules. The reason it needs to be in kilojoules is because in a minute I'm going to use Gibbs free energy change, so delta G equals delta H minus T delta S, and delta H is in kilojoules, so I've got to get this in kilojoules. So I'm going to divide by 1,000 to get joules into kilojoules, a small unit value into a larger unit value. I divide by 1,000, and now delta G equals delta H minus T delta S. So delta H is minus 60, and I've got them both in kilojoules now. Kilojoules and kilojoules for delta H and delta S. Temperature. Now temperature is given in degrees C, and it needs to be in Kelvin. So this temperature is in Kelvin. So I'm going to take 298, I'm going to add 273, and I'm going to multiply by my 0.141, which is my entropy change. Delta G, therefore, is minus 238. I'm going to put it to 3 significant figures because everything else in the question is to 3 significant figures, and whether it's feasible or not, well, if delta G is 0 or less than 0, negative in other words, then it's feasible and going to go ahead.